Next, we are going to learn about work. We learned about force. Now we are going to learn about work. In our day-to-day life, we use the word work very frequently. Every time we use do that work, I have this work, I have some other work. That work word we are using every day, isn't it? I have homework to do, I have some other work to do, and it means some job. We usually means work what everyone usually say about the work as a job. But in science, it has some other meaning. Okay, it has a specific meaning. We say when you use force to move things, you do work. We are forcing. We are pulling an object using some force. It is moving through a distance. Means we are doing a work. We say more work is done in moving the cupboard than in moving the chair. To move a chair, we don't want to apply much force. Simply it will move. But moving a cupboard, we need to apply a force with great effort. So different types of force. Applying the force means some object to move we can apply easily. We can apply the force, but some we need to move with a great effort. When force is used in an object and it moves through a distance, we say that work is done. When we apply a force to move an object, then we can say the work is done. For example, when a man lifts a weight to a certain height from the ground, so something is there on the ground, suppose a bag. So we are lifting that bag from the ground. So we are lifting. Okay. So we lifted that bag from the ground. So we are applying some force and we are taking it, right? Simply that we can't take like this. If the bag has weight, we have to apply some force and we have to take that bag. So we are applying a force there. That force is nothing but muscular force, we say. Muscular force. Muscular force means what? Muscular force. When we do some physical work, we are having this muscular force. Doing some physical work. Doing some physical work, we use this muscular force. We use this muscular force for running, jumping, cycling, for everything, or breathing, lifting. For all this physical work, we need this muscular force, or we use muscular force when we do some physical work. Lifting, we are using our muscles, some muscular force. We are applying some force on the muscles and we are lifting it, isn't it? So doing some physical work, we need muscular force. So lifting an object from the ground, we use muscular force, which he exerts does work against the force of gravity. Force of gravity is always attracting that thing to the earth, but we are taking it from there, isn't it? It has an attraction towards the earth, but we are lifting it up, isn't it? Yes. Work is done when a load is lifted. When we lift our body above the ground, when we climb stairs, throw a ball into the air, or even when we open a door, or we crack a nut, break a nut. In all these activities, we are doing some work. So in simple words, when force is applied on a body to make it move through a distance against the force of gravity, work is done. Work is done means when we apply a force on a body to make it move through a distance, then work is done against force of gravity. Force of gravity is always attract towards it, but we are making it move away from that, or we are lifting it so against the force of gravity, then work is done. Work always involves overcoming some opposing forces. Yes, here opposing force is force of gravity. Gravitational force always make the body to attract towards it. We are taking it from there, isn't it? Secondly, when we push some heavy objects like a box, we work against the frictional force. So the resistance is either against the force of gravity or the frictional force. When we move a heavy object, just like an example, last example, a man is pushing a heavy box which is very heavy. There the opposing force is frictional force, because that box is there because of frictional force, static friction, and we are trying to move away from that static force. But when we lift a thing, the opposing force is force of gravity. So in general, we can say work is done when you apply a force to make the body to move to a certain distance. Then we can say the work is done. In science, work means it has a specific meaning and a very important meaning. It is not like simply we are doing work. When you apply a force to move an object through a distance, then we can say that work is done. So that is about work. Next comes what? Yes, energy. Energy is the ability to do work, the capacity to do work. To do some work, we need energy. If we are so tired, we won't be able to do any work. We should have energy to do all the work. A car needs energy to move. Wind needs energy to make trees sway. So, have you seen in strong wind and all, we can see the tree is moving. So to do that, wind also need energy. If it is strong wind, then only the trees moves. Energy is required to change matter. Matter means any object. All objects are made up of matter, we say. So to change it, we need energy. Energy is available in different forms such as heat energy, light energy and electrical energy. Capacity or ability to do work is called energy. Nothing in this world can work without energy, isn't it? Nothing in this world can work without energy. Like vehicles move because of energy. TV, refrigerator, computer, music system, everything works on electrical energy, we say. Okay. So all objects in the universe, they need energy to work. Plants need energy from sunlight to make food. Then they can make food. They need energy from sunlight. We human beings need energy, get energy from the food we eat. Then only we can able to do the work. So everything in this universe works on energy, or nothing in this world can work without energy. All objects in the world requires energy, and capacity to do work is called energy. To do any work, energy is used. A body is said to possess energy when it is capable of doing work or of overcoming resistance. Overcoming resistance means we have to overcome that opposing thing or opposed force. We have to overcome that. Then thus work and energy have strong relationship. Energy is spent when work is done. Energy is stored, capacity to do work. Energy is stored here in our body. Then only we can do the work. From food we get energy, isn't it? So that energy is called biochemical energy. The food we eat, it goes inside our body. Then we get energy. Then we do some work. So we can say that biochemical energy is converted to chemical energy. This energy is, you can convert from one form to another, children. It can't be created or it can't be destroyed. Energy can't be neither created nor destroyed, but it can transform from one form to another. Like the food we eat, we get biochemical energy. When we do work, we are doing some mechanical work. So what biochemical energy is converted to mechanical energy, we say. When light is on, we can say heat, because of heat energy is converted to light energy there. Plants prepare food through photosynthesis, you learned. So using sunlight they are preparing, sunlight, water and all. So the light energy is converted to chemical energy, we say. So energy conversion is taking place, like from one form to another. We can't create it, we can't destroy it, but it transforms from one form to another. Then energy moves cars along the roads and make aeroplanes fly. It plays our music on the radio and lights our homes. Energy is needed for our bodies together with plants to grow and move about. As I said, nothing in this world can work without energy. All objects in the universe need energy to work. Cars moves energy to move. All the vehicles need energy. TV, refrigerator, computers, music system, radio, everything need electrical energy. Plants need energy to make the food. We human beings need energy to do some work. So energy is stored in our body, then only we can do the work. So energy is stored, capacity to do work. That is nothing but energy. So I already told, energy means we can convert from one form to another, or there are different forms of energy like heat energy, light energy, chemical energy, electrical energy, etc. So now we are going to learn about all these different types of energy. As we learned about different types of force, like frictional force we learned, gravitational force we learned, same like the energy also there are different types are there. Now we will learn about different types of energy. Okay children? Yes children, so we learned about force first, isn't it? Force, a push or a pull of an object is called a force. If we need to move an object, we need to apply force. Force is needed to move an object, to stop an object, to change the direction of an object. For all these things we need force. It is a push or pull up to an object, isn't it? Yes. And in force itself we can tell about, there are different types of force, or one is friction. We learned about friction, isn't it? Frictional force. Friction is nothing but when you roll a ball, what happens? After some time it reduces its speed, it lessens its speed and it stops, or it comes to rest we say, or it stops. That stopping force is nothing but friction. And when we rub our hands together, two surfaces are in contact, heat is produced when you rub your hands together. There also frictional force is there. To stop the ball, that frictional force is there. Or when we walk, when we run, we are not falling down, slipping down. Frictional force is helping us to walk, to run, okay, on the road, because our shoes or our sandals are in contact with the surface, another surface. When two surfaces in contact, then friction force come into play. Then every body in the universe is attracted towards the earth. It is nothing but force of attraction. That force of attraction is nothing but gravity. All objects, when we throw up, it comes down or falls down because of the force of gravity. Fruits falling down. When we throw a ball, it falls down because of force of gravity. So Earth's attractional force or gravitational force attracts everybody towards the earth. Okay, that's why when we lift a body, something up, we are applying some force against the force of gravity. Okay, so when we lift something up, we are doing some work there. We are taking a body from this position to a little bit up, changing the position. When we move an object, it is moving, so it changes its position. So work is done there. When we say work is done, when we move an object through a distance, which is called nothing but work. Work is done when we move an object through a distance. So to do the work, we need energy. Nothing in this world can work without energy. So energy gets from the food we eat. All objects in the universe need energy. Nothing can work without energy. So there are different types of energy, or energy is called the capacity to do work. Now we are going to learn about different types of energy. First is thermal energy. First, thermal energy. Thermal means what, children? Thermal means heat. It is also known as heat energy. Thermal energy is also called heat energy, or we say energy that is generated and measured by heat, we say. Okay. Matter is made up of particles or molecules. Every object in this universe are made up of matter. It consists of some particles, we say. Particles means molecules. These molecules move, means vibrate constantly. A rise in temperature of matter makes the particles vibrate faster. Rise in temperature means nothing but heat. Because of heat, the particles will vibrate or move faster. When we heat water in oven or in a stove, what happens when the heat increases? We can see the water molecules vibrate faster. So rise in temperature, when it heat more, the particles or molecules move faster, vibrate faster. Thermal energy is what we call energy that comes from the temperature of the matter, from the heat, we say. The hotter the substance, the more the molecules vibrate. As I said, the example of heating water. When it boils, what happens? It will vibrate faster. Therefore, the higher it's, therefore when the heat is more, thermal energy is more, we say. So that is heat energy. So this energy we use for example of thermal energy is cooking, baking, water heating, in oven or stove, wherever heat is there, the thermal energy is there. Okay, that is about thermal energy. Next is about light energy. Heat energy we learned. Thermal is also known as heat energy. Now we are going to learn about light energy. The potential for light to perform work is called light energy. The ability or the possibility of the light to work is called light energy. Light energy is only a form of energy that we can actually see directly. We can, through our visible eyes, through our eyes, we can see light is working. So it is the only energy that we can see directly. It is formed through chemical radiation. Radiation is a form of light, children. Light is a form of radiation actually. That's why it is light. It is formed through chemical radiation, we say. Light means it is radiation itself. Because visible light, isn't it? Light is visible. That's why it is a form of radiation, we say. Light energy can also be converted to other forms of energy. Example, when I say like photosynthesis, plants prepare food by photosynthesis. So plants make use of light energy from the sun. So there what is happening actually, using the light, plants prepare food, and this light energy they are converting to chemical energy through photosynthesis. So light energy can be converted to other form. When the light is glowing, when the light is on, after some time when you go and touch it, we can feel the heat on that, isn't it? So light is converting to heat, light energy is converted to heat, isn't it? So, energy, light source. See the image over the image you can see here. Light is a light source. From that energy, light energy is emitting. Then here other side we can see a phase on that eyes, photoreceptors we say. Photoreceptors, they are special cells in eye retina, we say. Photoreceptors means they are specially designed cells in our retina, behind the eyeballs. These eyeballs, black color eyeballs are there. Behind that the special cells are there. They are known as photoreceptors. Through photoreceptors we can see everything, like it gives us color vision, we say. Color vision, at night we are able to see colors, we are able to identify because of photoreceptors. Okay, they are the cells on the retina that respond to light. When light is on, when our eyes see it, or we are able to detect it, it is visible, that because of the photoreceptors in our retina, behind the eyeball. Okay, so our eyes are specifically designed to detect the light. So light is a form of radiation, we say, or light also is a form of energy, we say. Okay, that's about light energy. Now comes electrical energy. Actually, what is an electrical energy? We can say it is a moving energy. Electrical energy. All electrical appliances like TV, refrigerator, music system, computer, all works on electrical energy. We can say it is a moving energy. It results from the flow of electric charge actually. Electrical energy means some flow of charge is going through that wire. These all electrical appliances, mixie, grinder, refrigerator, TV, works on electricity only. When the power is on, the plug, when we connect it and power is on, it will work. Why? Through that wire, some flow of charges, some charges are flowing through the wire. We are not able to see that. That's why I said light energy is only thing we can see directly. The other things we can't see it. So inside the wire, some flow of charge, something is moving there, making the appliances to work. So a moving energy, it is nothing but light, electrical energy. Electrical energy is the energy that's stored in charged particles within an electric field. Electric field are simply areas surrounding a charged particle. Some charges are flowing over there. That's the meaning, children. In other words, charged particles create electric fields that exert force on other charged particles within the field. When we connect the wire to the switchboard and when we on it, it is charging. We are charging it. We are charging mobile. Mobile gets charged. Current is flowing through that wire. That's why the mobile is getting charged. Okay. So this electric field applies the force to the charged particle, causing it to move. In other words, do work. Some work is going on there, or some flow of charge is going through the wire. It makes the things to get charged or to work. That is electrical energy. Now next is sound energy. So what is sound energy? Sound energy it is the only energy that we can hear. This is the energy that we can hear. It's a type of energy. It is made by the vibrations when any object vibrates. If anything makes sound, if someone is making sound, so some drum beats if we heard, music if we hear, something is vibrating, isn't it? That vibration, it causes some movements in the air particles. So in another house, if music they play, from our house we can hear. Neighbor house, something some music they are playing, but we are staying next to that, but still we can hear it. How? Through air. That vibration is passing through the air and it is reaching our ear and we are able to hear it. So sound energy is the energy produced by the vibration of sound waves, we say. Vibration of that image you can see. From other area, some sound they are doing with some drums or beats or some music, whatever, that sound through air, it is that vibration, the particles are moving through the air, it will reaches our ear and we are able to hear it. So it is the energy that we can hear. It is produced by the vibration of sound waves, we say. I am talking, you are hearing. So, isn't it? So when your friend talks, you hear it. So through air, that particles are moving and reaching our ears and we are hearing it. So these are the different types of energy. We learned about thermal energy. Thermal energy is nothing but heat energy. If any substance is heating, then the thermal energy is there. When rise in temperature, when more heat, more energy, heat energy. Example, boiling of water or cooking, cooking, heating, whatever if we heat, if in oven or in stove, thermal energy is there. These are the examples of thermal energy, cooking, heating, etc. Then light energy, it is the only energy that we can see, it is visible. Light is a form of radiation, we say, because it's a visible light. And photoreceptors, that is there behind the eyeball, in the retina, photoreceptors are there. They are specially designed cells to detect the light. Because of photoreceptors, we are able to see the color light, and also the night vision is possible because of photoreceptors. Then we learned about electrical energy. Electrical energy is nothing but moving energy, flow of energy through a wire or something makes the electrical appliance to work or move. Flow of energy. Then we learned about sound energy. It is the only energy that we can hear it. When anyone makes sound, what is happening? That it gets vibrate, particles vibrate, and in the air it will move and it reaches our ear and we are hearing. That is sound energy. So thermal energy, light energy, electrical energy, sound energy. Okay children?